Students, this lesson is for February 11th. We're also going to be taking our checkpoint this day, so we'll spend about an hour working on this kind of stuff in class, and then we'll take our checkpoint the last half of the period. We're going to work some area and volume problems. We're going to bring back some geometry stuff that you learned back in middle school, and we're going to do that with exponents. We're going to be using our EOC formula chart to do it. This is the same formula chart that you guys will use this year on your Algebra 1 EOC test. So you can see that there are geometry formulas in this area right here as well as down here. So even though you're taking an algebra test, they still expect you to be able to use these formulas that you learned back in middle school. And we'll put them to use over here for the next couple of pages. Well, it says find the area, assume all measurements are in centimeters. So the first thing you have to do is identify the figure. This is a rectangle or a parallelogram. So if you look back at the formula chart on the other page, we learned that area is base times height for this type of figure. So this would be our base, this would be our height. So we plug in. Our base is 2x y to the fourth, and our height is 5y. And so this is a multiplication problem, so we'll use our multiplication rules from last class period, where we just multiply the numbers. 2 times 5 is 10, and with the letters we add exponents. So this is x to the 1, there are no other x's, so that stays x to the 1. This is y to the 4, and y to the 1. 4 plus 1 is 5, so y to the 5th. And this is our answer for that area. The second one is a square. We know that because of these symbols indicate that all sides are equal. So we can label this other side over here as 3mr to the second. Square falls into the same category as a rectangle in the parallelogram group, and so it is base times height also. So here's base and here's height. So our base is 3mr to the second, and our height is 3mr to the second. Again, we multiply numbers. 3 times 3 is 9. m1, m1, 1 plus 1 is 2. r2, r2, r4. So 9m squared r4. Next figure here is a triangle, and the formula for triangle is 1/2 base times height, or base times height divided by 2. So either one of those works. I think let's function under base times height over 2. So this is base, that's height. So our base is 7s3t2 times the height of 4s all over 2. So we'll do the top part first. 7 times 4 is 28. We'll keep that over 2 for now. S3, and that's an S1, makes S4. T2 and nothing else stays T2. And then this part, we can just treat these numbers like normal. 28 divided by 2 is 14. S4, T2, and we are done. Okay. Number 4, this is a circle, and the area formula for circles is pi r squared. Leave in terms of pi means that we really won't deal with pi. We'll just leave it in the problem, and won't mess with it. So pi, this is our radius. So radius 4j to the third squared. So this square goes to the 4 and to the j3. So usually we put the pi on the right hand side and put all our numbers and stuff first. So 4 to the second would be written like this, 4 to the second. J3 and 2, this is a power to power rule, and that is multiply, so this becomes J6. Well, 4 squared we can do. 4 squared is 4 times 4. And so that is 16 J6 pi. And so that's the answer for that one. Alright, so here it is just in words. So I would say anytime you get these, you should draw your own pictures. So given a rectangle with a side of 6x3, y3, z, and this has an area, so the inside part is 24x5, y4, z, and you're trying to find the missing side. So this is the opposite of what we were doing a minute ago. We're trying to multiply 6 times what would give you the 24. So the easiest way to do that, and you learned this back in middle school, is to work backwards, is to divide. So you take the area, 24x5, y4, z, and you divide that by the side that you have, 6x3, y3, z. 6 divides into 24 and leaves us with 4, and that 4 is going to be on top. x5 and x3 The rule we learned in class was you move to the bigger one, so we do 5 minus 3 is x2. y3 and y4. You move to the bigger one, 4 minus 3 is 1, so y1. And these are both z1, z1, 1 minus 1 is 0, so there are no z's. So there's actually nothing on bottom, so that is our answer. 4x squared y. You could test that out real quick. 4 times 6 is 24. x2 and x3 is x5. y1, y3 is y4. z, z. So 4x squared y did work. Okay. Alright, these are volume. Typically the volume formula you learned back in middle school was volume equals length times width times height. So length, width, height. Okay, so it's really just a multiplication of 3 things in a row. Okay, so I'll write it out here. Our length is 3a squared. I'm not right there, I'm going to write it here. 3a squared bc times our width, 5b7c, times our height, 2a4b2. Numbers, 3 times 5 times 2, 3 times 5 is 15, times 2 is 30. a2 and a4, 2 plus 4 is 6, so a6. This is b1, b7, and b2. So 1 plus 7 is 8, plus 2 more is 10. So that's b10. c1 and c1 makes c2. Okay. For pyramids, it's the same thing except it's length times width times height divided by 3, or 1/3 of the length, width, and height. In this one we have a square base, so this base is 5j3k2 on both sides. So our length and width will both be 5j3k2, so this will look like this: 5j3k2, 5j3k2, and a height of 3j3k3, all divided by 3. So 5 times 5 times 3 is 45. j3, 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 3 plus 3 plus 3 is j9. k2, k2, k3, 2, 4, plus 3 more is 7, so k7, all divided by 3. Then 3 goes into 45 15 times, so your remaining answer is 15, j9, k7. Alright, number 3, to do the volume of a cylinder, it's the area of a circle, which is pi r squared, times the height of the cylinder. And we're going to leave it in terms of pi, which means we just won't mess with the pi. So we do pi. Our radius is right here, so e3f2 squared times our height. This thing is laying on its side, so that is our height, 4e2f. So we got to take care of the squaring first, so we're going to do the square to those. When we do that, that's a power to power, so that's a multiply, so that becomes e6 and f4. We keep the pi. Nothing is done with the 4e2f. Alright, when we go to multiply, 4 times nothing, so we have 4. e6, e2, 6 plus 2 is 8. f4, and that's an f1, is f5. And then we just put our pi to the end. And that is our answer. Alright, so given a cube, so we have a cube here. In a cube, all sides are the same, so 4p q2 r3, 4p q2 r3, 4p q2 r3. And this is a box, so it still follows length, width, height. Okay? So we're just going to put these all multiplied together times each other. 4 times 4 times 4. 4 times 4 is 16, times 4 more is 64. P1, P1, P1 makes P3. Q2 plus 2 more plus 2 more is Q6. R3, 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 3 plus 3 plus 3 is 9. And that is the answer to that one. Okay. The next ones, we get out of the geometry and go back more into some algebra stuff, but we have to use our exponent rules and our double rainbow and combining length and stuff that we learned earlier in the year. So here we should start to show them an example of the double rainbow. Okay. So negative 5 times 5 is negative 25. R4, R6, add them to make 10. S9, S1 makes S10. Then negative 5 times negative 3 is positive 15. R4, R2 is R6. S9 and nothing else is S9. Then you look at the remaining two and see if there are like terms, which there are not in our case. If there are no like terms, then you're done. The next one, we're going to double rainbow here and here. So that's an M5 and an M1, so that's 2M6. 2M times a positive 3 is 6M5. And this gets double rainbowed. Negative 4 times 8 is negative 32. M2 and M3 is M5. Negative 4 times negative 1 is positive 4. M2 and M5 makes M7. And then we look through here. Like look for the biggest one to start. So 4M7 is the biggest one. There's nobody to combine with that. Nobody to combine with the M6. And then 6M5 minus 32. So 6 minus 32 is 26. So negative 26 M5. No other like terms, so you're done. Alright. The last one here is just when you're adding two polynomials. So this polynomial plus that one. It's the same as like distributive property. You'd be distributing 1 to everybody there and a positive 1 to everybody there. And when you multiply things by 1, nothing happens. So this just becomes 2x to the third plus 3x minus 9. Same thing over here. The parentheses basically just go away and it becomes a big combining like terms. 2x3 and 2x3 is 4x to the third. Remember, we do nothing with the exponents on that. 3x minus 1x is 2x. Negative 9 plus 7, negative 2. No other like terms, so that one's done. The difference in this second one over here is you're distributing a 1 here and nothing happens. But here you're distributing a negative 1 and that does cause something to happen. What it does is it causes everything to change sign. So negative 3a squared becomes positive 3a squared. Positive 5a becomes negative 5a. And negative 1 becomes positive 1. And then we start looking for the biggest one. It's 3a squared. 5a minus 5a, those cancel out. 3 plus 1 is 4. No other like terms. I'm done.